Analyze the relationship between the reactions. Compare the two given intermediate reactions to the target reaction. Reaction 1. 2S plus 2O2 is in equilibrium with 2SO2 quad K1 is equal to 2 times 10 to the power 105. Reaction 2. 2SO2 plus O2 is in equilibrium with 2SO3 quad K2 is equal to 7 times 10 to the power 24. Target reaction. 2S plus 3O2 is in equilibrium with 2SO3 quad K3 equals. Determine how to combine the equations. Notice that adding reaction 1 and reaction 2 together yields the exact stoichiometry of the target reaction. 2S plus 2O2 plus 2SO2 plus O2 is in equilibrium with 2SO2 plus 2SO3. The intermediate product 2SO2 appears on both the reactant and product sides and cancels out, leaving 2S plus 3O2 is in equilibrium with 2SO3. Apply the rule for combining equilibrium constants. When two or more individual chemical equations are added to produce a net overall reaction, the equilibrium constant for the net reaction, K3, is the product of the equilibrium constants of the individual steps. K3 equals K1 times K2. Note, this is a key contrast to Hess's law for enthalpy changes, where individual delta H values are added rather than multiplied. Substitute the values and solve. K3 equals 2 times 10 to the power 105 times 7 times 10 to the power 24. Perform the scientific notation math. Multiply the coefficients and add the exponents. Coefficients. 2 times 7 is equal to 14 exponents. 10 to the power 105 times 10 to the power 24 is equal to 10 to the power 105 plus 24 is equal to 10 to the power 129. Kelvin 3 is equal to 14 times 10 to the power 129 equals math 1.4 times 10 to the power 130 approximately math 1 times 10 to the power 130. This matches option A. The correct answer is option A, 1 by 10 to the power 130.